Good day. In this video we will look at trigonometric rules of 2D figures as well as 2D representations of three-dimensional contexts. In this video we will be looking at how to use the cosine rule and the application thereof. Let's look at our diagram. Triangle ABC is given. It asks us to calculate or determine the remaining angles and sides for the triangle. My first question I would like to ask, seeing that I have AB, I have BC, and included angle B, why can't I use the sine rule? Why can't I? Here's an angle, no side. Here's a side, no angle. Here's a side, no angle. Remember, if you use the sine rule, you cannot have two unknowns. So here you will have an unknown of a side, and for both the other two, you will have an unknown of the angle. So you cannot compare them to solve the one or the other. Firstly, we will be calculating the side of small b by using the cos rule. At this point, I would hope and assume that you are familiar with the cos rule. B squared is equal to a squared plus c squared minus 2 into a into c cos of b. And if you want small b, you will have to find the square root of the aforementioned. So I substitute my values. The value of a, small a, is 12. The value of small c is 10. So I say 12 squared plus 10 squared minus 2 into 12 into 10 cos of 26 degrees. That gives me a length of 5,31878,0771. Rounded off, I get 5,32. The moment that I calculate something, I write it in on my sketch so that if I need to find anything else, I can have the information that I have available to me in order to determine my next step. Now that I have a side available opposite an angle, I can calculate angle A because there's only one unknown. When I have an angle and a side, an angle and a side, I can calculate C because now I have an angle and a side, and I have one side for the missing angle. So if we are going to calculate angle C, we will have to say sine of angle C over small c is equal to sine of B over small b. And when we write that out, we will make C the subject of the formula. Hence I will say the angle C will be equal to shift sine of 10 sine of 26. I post a question here. Why did I not calculate A first? Why did I opt to do C first? If you look at that picture, why do you think I opted to do C first and not A? I noticed that A is the longest side in this triangle. So potentially there could be an acute angle or an obtuse angle triangle. So that's why I prefer to calculate C first, then I will get the accurate measurement of angle A. So when I substitute my values, I get 10 sine 26 degrees over 5,32 centimeters. That gives me an angle size of 55,487. So 55,49, and if I have to do it to one decimal place, 55,5 degrees. Now generally when we work with angles, we will round off to the nearest tenth, meaning one decimal place. Distances we will normally round off to 2 decimal places, but for angles we prefer to have 1 decimal place. Can you figure how we will calculate A? Will we be using the sine rule? Will we be using the cos rule? What method and what approach will we take to solve the angle A? There we have it. We will subtract them from 180 degrees because the angles of a triangle add up to 180 degrees. So 180 degrees minus 26 plus 55 in brackets, that gives me 98,5 degrees. The size of angle A is 98,5 degrees. Before you pack up, make sure that you answered all the questions. The question asked us to calculate all the unknown values for the triangle, the angles as well as the sides. We have 3 sides, we have 3 angles, so our story is complete. Thank you for watching the video. See you in the next one. Trust you loved it and that you will share your experience with everyone.